In this video, we're going to talk about how to use CPCTC in two-column proofs. So first, let's review the four postulates that you need to prove that two triangles are congruent. The first one is the side-side-side postulate. So in this case, all three sides must be congruent. If they're congruent, then you could prove that the two triangles are congruent. After that, you have the side angle side postulate, where you need a side to be congruent, the included angle, and another side. After that, we have the angle side angle postulate, where you need an angle to be congruent, and then a side, and then another angle. The side has to be between the two angles. And finally, there's the angle angle side postulate. In this case, you need an angle to be congruent, another angle, and then the side. Now consider these two triangles. Let's say the first one is triangle ABC, and the second one DEF. Once you prove that two triangles are congruent, let's say ABC is congruent to DEF, then you could use CPCTC to prove any portion of these two triangles are congruent. So CPCTC is usually the last part of the reasons column in a two-column proof. It basically states that corresponding parts of congruent triangles are congruent. So if these two triangles are congruent, I could say that AB is congruent to DE. I could say that angle C is congruent to angle F. I can make any statements about any corresponding parts and show that they're congruent, or state that they're congruent based on CPCTC if I prove that the two triangles are congruent. So the best way to learn this is through a series of practice problems. So consider these two triangles. Let's call the first one triangle ABC and the second one triangle DEF. Now you're given that AB is congruent to DE, and also BC is congruent to EF, and that CA is congruent to FD. So your task is to prove that CA or rather, let's change it. Go ahead and prove that angle C is congruent to angle F. So let's make our two-column proof. Statements, and reasons. So the first statement that we could say is that AB is congruent to DE. And the reason for that, it's given. So let's write that on the picture. So this is AB is congruent to DE. Now in step 2, we could say that BC is congruent to EF. And that's given as well. So here's BC, and it's congruent to EF. Now in step 3, we could say that CA is congruent to FD, and that's also given. So now what postulate can we use to prove that these two triangles are congruent? So in step 4, we could say that triangle ABC is congruent to triangle DEF. Now make sure you write this in a certain order. Notice that A corresponds to BC, and D corresponds to EF, and BC is equal to EF based on the two tick marks that you see there. So A has to match up with D. B is opposite to the side with 3 tick marks. The same is true with E. So when saying two triangles are congruent, B has to match up with E. F is across the side with 1 tick mark, and C is across the side with 1 tick mark. So C and F correspond to each other. So for those of you who might be wondering how you should write these letters and in which order, make sure that the first two angles match up. Angle A has to be congruent to D. And typically, if the sides are congruent, then the angles opposite to those sides has to be congruent based on the side angle theorem. Now we can say that these two triangles are congruent based on the side, side, side postulate. Now we've used statements 1, 2, and 3 to show that those three sides are congruent. So let's put 1, 2, and 3. Now once you prove that the two triangles are congruent, the last step, in my experience, is always going to be CPCTC. Now you can prove that any corresponding parts of these two triangles are congruent. In this case, we can say the final sentence or make the final statement. So we can say that angle C is congruent to angle F based on CPCTC. Corresponding parts of congruent triangles are congruent. And that's it for this problem.